This is my deep learning and poster. My name is JacobMantooth. I go to East Central University. I'm a junior, majoring in mathematics and physics. And this is my research over the summer and fall, continuing on to the spring. What we want to do is understand deep learning, which, if you don't know what deep learning is pretty much in your everyday life, from Siri to Google Map to Tesla cars, anything that requires an input and then has to predict the output is using deep learning. This is this complex machine learning that uses mathematics. That's all it is mathematics deep down. It uses a linear and nonlinear and mixes them together to make an output. Here's our example data. We use MIST dataset, which is just handwritten digits 0 to 9 on a piece of paper. We did some data exploration on this, where we did a count and a heat map. And on a heat map, we got some weird things going on. We got some things we figured would be on there, like every pixel would have the next pixel would be strongly correlated with each other. But we found these like weird box outlines, and we had this theory that these box outlines were just the black edges, because as you can see up top, it's just like the edges are mostly black. And so we want to visualize this, and so we did the medium, mean, standard deviation, minimum, and max. The 4 really didn't tell us, but the maximum told us. Like the maximum of all of our digits, as you can see, the edges are pretty much black, which is why we're getting these weird square shaped things in our heat map. We created our model. Our model was a 1-layer, really simple model. We inputted our data set, which had 784 inputs, and we wanted to predict 10 outputs for on a digit. And so this is 1 layer, super simple. And we did this, we ran this 3 times so it could learn on it. So 3 times, and as you see at the last time, it was getting 91% accuracy, which just shows you how powerful deep learning is. Just with 1 layer, we were able to predict 91% accuracy, which is crazy to me. So after that, we wanted to see what if our model could do a simple logistic problem, which is where XOR model came in. XOR is a simple logistic model you learn in any intro to theorem proving class, any computer learning class. Very simple. And we could do it pretty easy on paper, but our machine learning could not at all. We tried with multiple layers, and it just couldn't work. It was just guessing pretty much. And this was one of our better output where it almost guessed it right, but it was just guessing. And so we wanted, being a mathematics major, we wanted to explore this more. So we created a manual example of the XOR, where we produced the output where we wanted, given a certain kick to it. We gave it a little kick, and it was able to produce the output. And here's the function we use. As you can see, it's a linear function with a nonlinear spice to it. And then our first thing we started with is PCA and linear regression. We said that somehow they're related at the beginning of our project. Throughout the semester, we were testing how are these connected. We couldn't find a way until we performed the PCA on the linear regression, and what we found is the first PCA lies on the same plane as the linear regression, and we were able to prove this too. And that's the end. I want to say thank you to McNair, NASA, LSAMP for funding us.